These are normal distribution questions, problems from Oxford, IB, Applications and Interpretation SL textbook. It's chapter 7 on normal distribution and it's exercise 7M. Okay, so we're going to go through these. This particular video goes to 1, 2 and 3 and the next video will be 4, 5, 6 and 7. Okay, question 1. The length of a local bus journey from Unrise home to school is a normally distributed random variable T sub L with mean of 31 minutes and a standard deviation of 5 minutes. Sketch the following events on 3 separate diagrams. Okay, so this value here is greater than or equal to 31. Okay, now I'm using this particular diagram. I've written it down here as it's distributed normally. Remember, that's the mean. This is the standard deviation. Okay, it's the same for all because that all comes from here. 31 minutes is the mean and the standard deviation is 5 minutes. Now this is what we know. Remember, one standard deviation from the mean is about 68% of values, and 2 standard deviations away from the mean is 13.5% plus 34% on either side of the mean. Okay, but what I've actually done here, it's a bit hard to see some of these numbers, but I've put in what they wanted us to do: sketch the following events on 3 separate diagrams. So let's have a look at it first. We've been told that the mean is 31, so that center line there, the line of symmetry, is 31. A little bit hard to see, but that's what that is. And if the standard deviation is 5 minutes, that's all going to be. This is actually represented as standard deviation at the moment, but you could represent that as minutes if that was the case. That point there would be 31, and then plus 5 is going to be 36, and minus 5, or 5 on the other side, is going to be 26. Okay, so that's what that would be, and it's asked us to do greater than or equal to 31. Well, that's just going to be greater than or equal than to the mean, so it's this half. It's 50% of the values. It's all of those. This one here. Okay, so in this case, they've asked us to find between T sub L. T sub L is greater than or equal to 29 or less than 32. So what I've done is I've labelled this again. The mean is the same at 31. The first standard deviation is at 36 and at 26 on the other side. Now they wanted us to go 29. Well, if that's 26 and that's 31, 29 is about here, because it'd be 26, 27, 28, 29, 30, 31. So it's greater than 29 and it's less than 32. Again, if that's 31 and that's 36, so that's 35, 34, 33 and 32. Okay, and it's between those two, between 29 and 32, so I've shaded that area there. This one here, number C, it's less than 36. Okay, the probability of it being less than 36, well again, that's the mean at 31. The one standard deviation to the right there is 36, so we have to shade all of that area because remember it's from all here, from 0 to 36, and it's because it's less than 36, so it's all that area there. That's quite good. Okay, question 2 is quite similar. The length of an express bus journey from Unrise home to school is a normally distributed random variable TE with mean 25 minutes and standard deviation 3 minutes. Sketch the following events on 3 separate diagrams. Okay, well this differs from question 1 because this is an express bus. The first one, A, look, I'm using the same basic diagram here and I'm adding to that. The first one is this random variable T sub E, express, is greater than or equal to 31. So greater than or equal to 31, remember in this case we've got 25 as the mean, so that's the center line. Then 3 is the standard deviation, so that's one standard deviation to there, so that's 28. That's another standard deviation there, so it's 31. Okay, that's 31 right there. And that's what they've asked us, greater than or equal to 31. So it's from that point there, which is 2 standard deviations from the mean. It says it's greater than 31, so it's that shaded area right here. B, the random variable T for the express, it's greater than or equal to 29 and less than 32. So in this case here, well, it's the same mean, 25. It's the same standard deviation, which is 3, so that's 25, that's 28. This one here is 31. Now we're looking to get up to 32, so it's more than 31. Well, that one there would be 34. Remember, it's 31 plus another 3 is 34. So 32 would be here, okay? And the minimum we've got on the domain here is 29, so it's 29, because that's 28, so that's 29 and to here. So we just shade that area in. Now C is less than 36, okay? So if it's less than 36, we just count again. We've got 25 as the mean, because they told us that. Standard deviation is 3, so the first standard deviation is 28. The second standard deviation is 31, then it's 34, then it's 37, and it's getting very, very narrow down here. But they wanted 36, which is just less than 37, so I've just shaded everything in there. Question 3, a large sample of bottles of shampoo are inspected. The contents of the bottles S is distributed normally with mean of 249 mils and a standard deviation of 3 mils. A, sketch a diagram to represent this information. So I've written it like this. S is distributed normally. The mean is 249. The standard deviation is 3. So our center line is 249. One standard deviation is 3 plus 249, which is 252. And one standard deviation the other side is 249 minus 3, which is 246. B, hence, estimate the probability that a randomly selected bottle of shampoo will contain less than 246 mils. They don't want us to use the GDC here. From the diagram above, S is less than 246 mil. Well, 246 was recognised as one standard deviation from the mean. So we know that 50% of the values are less than the mean. So the way the textbook did it, they just did 50% minus 34, and they got the remainder part here, because that's the part we're interested in, less than 246. The way I did it is I just added up the 0.15, the 2.35, and the 13.5 to get this area here from minus infinity to here, okay, because that's at the point of 246, and we got a probability of 16%, which was 0.16. C, verify your answer using technology. Well, we use technology. We use the, I use the Ti-nspire, and you can also use the 84, quite straightforward. You go to probability, distributions, normal CDF, and we know that the mean is 249, the standard deviation is 3. We know that we want to get the domain, basically, this along here, is going to be less than 246. So in the calculator for this normal distribution CDF, you put in, the first thing you put in is minus infinity, which is automatically in there with the Ti-nspire. And then you put in, well, the Ti-nspire CAS, and then you put in 246 in there as well, and then you put 249 as the mean, and you put 3 as the standard deviation, and you'll get this number here, which is to 3 significant figures 0.159, and that matches quite well with what we estimated from the diagram. D, the bottle is labelled contents 250 ml. Predict the number of bottles in a sample of 200 that will contain at least the amount claimed. Well, at least means 250 or above. So X is greater than or equal to 250 mil, or greater than or equal to 250 mil. So it's the, again, S is distributed normally, 249 to 3 there, 249 mean and 3 standard deviation. Now, because we're interested in above 250 and above, when we calculate on the calculator, we're actually, remember, it's always measured from the left-hand side, okay? So what the calculator will give us, it'll give us from here to our value of 250. So that's just above the mean. Now, once we get that value, we've got to actually do 1 minus that value, because we're not interested in left of the 250, we're interested in the right side of the 250, above 250. So that's why I've written it like this, is S is greater than or equal to 250 is 1 minus S is less than or equal to 250, and that became 0.36944. And then the part here said, predict the number of bottles in a sample of 200 that will contain at least the amount claimed. Okay, so this will be binomial. It's either, in 200 trials, it's either above 250 or below 250. We know that the probability of above 250 we calculated as 0.36944. So that goes in here. Remember, X is distributed binomially. 200 trials, this is the probability of it being above 250. So the expected value is just N times P, number of trials times the probability of it occurring, and that came out to be 73.8883, which I've put down as 73 bottles The textbook says 74. I think you could make an argument either way, whether it would be 73 or 74 for this question.